Okay, let's do a few more u substitution examples. Here we have e to the 7x plus 1, so what would be the integral of that? Not a lot we can set u equal to here, so I'm going to set it equal to the power. U equal to 7x plus 1. Sorry about my focus. That means that du is equal to 7 dx. Like, I kind of skipped a step there. This is a differential. It's du dx equals 7, and then you can just move the dx over. All right, so that means we're pretty much ready to go. Now, this is an example of when it's a good idea to go ahead and solve for dx. So let me not skip a step. We'll take the derivative of this, so we get du dx is equal to 7. Then you can put the dx over like I did. Du equals 7 dx, like I had in the previous step. And then you can divide by 7. So if you don't see a really easy substitution like we had in the last two examples, then go ahead and solve for dx. So this now becomes the integral of e to the u, and then we replace dx with du over 7. Like that. All right, so we're almost there. Remember that we can pull a constant out of an integral in the same way that we can pull a constant out of a derivative. And so we have 1/7 e to the u du. And happily, the integral of e to the u is e to the u. So the answer is 1/7 e to the u plus c. And that's our answer. We go ahead and finish it up by plugging in the u substitution. So our final answer is 1/7 e to the 7x plus 1 plus c. Just like that. If you have any questions, please let me know. Notice it's basically the chain rule. If we take the derivative of this, an extra 7 pops out and cancels that 1/7. The c also cancels, and we get back to the original problem. 2 to go. Again, the trick to this is picking the right u. Try to pick something that when you take its derivative, it cancels something else in the problem. So take a look at this and see if you can think of what it is. Time's up. If you want to try, pause the video. The correct u substitution here is r to the 3 minus 1. You want to cram in as much as you can because when we do the derivative, it will make our derivative as simple as possible. Du is equal to r squared dr. And when I say r squared, I mean 3r squared. Sorry about that. So if we have u equals r cubed minus 1, then that means du equals 3r squared dr. And again, that's a differential. It's du dr, and then I just move the dr over. So du equals 3r squared dr. Now on this one, it might be a good idea to go ahead and just solve for dr. So we have dr is equal to du over 3r squared. The reason I'm using r is because instead of x is because that's our variable here. So with u and with dr, we're ready to do our substitution. So this is the integral of r squared times u to the 7. And then do you agree with that? R squared times u to the 7. And then we replace dr with du over 3r squared. Just like that. Okay? Notice now that the r squareds cancel, which is critical. If we have any r's remaining, we wouldn't be able to use this technique. We have to only be in terms of u. This 1/3 can come out in front of the integral. So we have the 1/3 times the integral of u to the 7 du, like that. So that's a lot simpler integral than this mess up here. Let's go ahead and do it. That will equal 1/3 times u to the 8 over 8 plus c. So 1/3 times u to the 8 over 8 plus c. So that's going to be over 24 on the bottom, because 3 times 8. And for the top, I'll just replace my u with our substitution, which is r to the 3 minus 1. And then we need to take that to the 8th power plus c. There you go. I know it looks easy when I do it, but I promise you will get better with practice. Just practice with your, I've said it 100 times, but it's important. Practice picking your U. Make sure that if it's not working out, if you can't make it work, then you've picked an incorrect value for U. And again, notice that this technique only works if this is very special. If I make this r to the 5 instead of r squared, the canceling no longer works. So notice that being r squared had kind of rigged it for us to work. U subs are only good in some limited situations when the chain rule has happened. All right, last one. We have 8e8t over 2 plus e8t dt. The correct U sub, pause the video if you want a chance to guess what it is before I do. The correct U sub is 2 plus e to the 8t. Notice that each one is the derivative of the other on this one, so which one should we pick? We should pick the one with more stuff that cancels. So du equals, the 2 cancels, the derivative of e to the 8t is 8e to the 8t dt, because it's a differential. All right. Next, what we can do is go ahead and start making our substitutions. Let's go ahead and solve for dt this time. dt is, and again, this step is technically optional. You can do this part in your head, but I'll go ahead and write it out since we're just doing this for the first time. So dt is equal to du over 8e to the 8t. So here's what it looks like after our substitution. We have u down here. Okay. Up here we have 8e to the 8t, and then we replace dt with du over 8e to the 8t. That happily cancels all of that, which is exactly what we needed to happen. And so look at this, we just get the integral of du over u again. Du. Oh, I already have the du, sorry. Do you remember what that integral was? Hopefully you do. The answer is the natural log. The natural log of u, technically, well, never mind, I won't get into that. Natural log of u plus c, technically be the natural log of the absolute value of u, but that makes sense because you can only put positives or into a natural log. Almost done. Make our substitution. And you are done. If you're not sure about yourself, like if it's on a test, just take the derivative, and if the derivative works out, then you know you got it. All right, we'll do one more example on the next page. I will see you in the next video.